Let's discuss question number 34. Okay, let's read out the question. This is from test 1, by the way. Let's read out the question. 2 kg of air is heated at constant pressure of 200 kPa to 500 degrees Celsius, and we need to calculate the entropy change. So this is a straightforward question from second law of thermodynamics, and so the question is from thermodynamics. 2 kg of air is heated, so you have air, okay, and let's draw it something like this. You have state 1, 2 kg of air at constant pressure. So basically it's something like I can just draw it as a piston where the weight of the piston is constant. It's constant pressure, 2 kg, okay, of 200 kPa pressure. Okay, I don't know the initial temperature, and this is heated. This is state 1, and state 2, the pressure is constant, so the piston weight is all same, everything is same. Okay, so pressure is 200 kPa, volume I don't know, temperature is 500 degree Celsius. So this is state 2. Okay, now what is asked is, okay, the volume is given, initial volume is given. So initial volume is 0.8 meter cube. So I don't know the initial temperature and I don't know the final volume. Okay, but pressure is constant. Remember, this is a constant pressure process. Now calculate the entropy change of the initial volume. Now entropy change, whenever it's asked, we use one of the two TDS equations. Now what are TDS equations? Well, the TDS equations are something like this: du plus pdv. This is one equation. The other equation is vdp. Now depending on whether volume is constant, we use either of these equations. So now these are used for entropy calculations, because the advantage of these equations are applicable either for reversible, irreversible. It doesn't depend whether the process is reversible or irreversible. These are just the relations involving property changes, because everything is property here: temperature, entropy, internal energy, pressure, volume. So these are applicable for any process. That should be this should be remembered in mind. Now what is its constant pressure? So I'll just basically use the second equation. Okay, so I get, because it's constant pressure, so TDS is dH minus VDP. This is 0 because it's constant pressure, dH. Now for ideal gas, air, okay, so dH can be written as CP dt, okay, so TDS is mCp dt, and now I need to find out from state 1 to state 2. So this is what is ds. Now change in entropy from T1 to T2 is this. So this is mCp ln T2 by T1. Well, I don't know T1, I know T2. T2 is 500 degrees Celsius. Now T1 I don't know. How do I find? I know mass, I know Cp for air. Well, mass is given 2 kg. Okay, Cp of air, you are supposed to remember, that is 1.007 kilojoules per kg Kelvin. So only thing I don't know is T1. Now can I find T1? Because air is ideal gas. At the initial state I know volume, I know pressure. So how do I find? So I can use the ideal gas equation. So if I use the ideal gas equation at state 1, I can write PV is mRT. Well, how do I find temperature? PV by RM, and R also is something which you need to remember, 0.287 kilojoules per kg Kelvin. So pressure is given 200 kPa, volume I know, which is given 0.8, mass is 2 kg, R is 0.287 kilojoules. So based on this, when I substitute everything, I get 278.7. This is where you have to use the calculator. So this is temperature, which is T1. Remember, these are all state 1, so temperature I know. Now T2 is given as 500 plus 273, so that is 773 Kelvin. So everything I know, I can use this equation to find entropy. So entropy is 1.005 ln 773 by 278.7. This when I calculate, I get close to 2.040 kilojoules per Kelvin, and therefore the answer is 2.040, and the option is close to B. Thank you. So to use TDS equation, depending on the volume is constant, pressure is constant, you have to use either of these equations for entropy calculations. It doesn't matter whether your system is closed or open, or the process is reversible or irreversible. These should be used for calculating. Thank you.